Welcome to Mr. Rafa Online Tuitions. Please don't forget to subscribe to the YouTube channel Mr. Rafa Online Tuitions. This is Physics 2024 Internal Final Exams. Section A. The diagram shows an extract from a vernier caliper being used to measure diameter of a pipe. What is the reading of the instrument? So we start with the main scale. For the main scale, we need to get the reading before 0. So this is the reading that we need to take. For your own information, we don't have a figure here. So instead, we'll start to move backwards. So our reading, this is our reading. So this is 10. So this reading, it is 9.9. So 9.9, that is the main scale. This is 9.9. So this is the reading that we need to take before this 0. So we don't need to cross this 0. So this is the reading that we need to take. Then we have also what we call the vernier scale. So the vernier scale, we need to take the vernier scale to 2 decimal places. So this is 0.00, 0.01, 0.02 on the consigned line. This is a consigned line. So we need to end on the consigned line. So we have 0.02. Then what do? You add. So you add. So 9.9 plus 0.02. So there you fill this gap with a 0. This is 2, 9. This is 9.9 centimeters. So the answer is B. So B is our answer. Number 2, the swing of a simple pendulum whose angle of swing, which is the amplitude, is 10 degrees, has a periodic time of 0.80 seconds. What could be the periodic time if the angle of the swing is reduced to 7 degrees? In this case, the periodic time will not change, will be just the same. So the answer is A. So what could be the reason? The reason is very simple. So for a small angles of the swing, the period of the simple pendulum is independent of the amplitude. So even if you reduce the angle of swing, the time taken for one complete oscillation remains the what? The same. So question 3, a digital balance reads 50 kg when a girl stands on it. What could be the mass and weight of the girl on the surface of the moon where the gravitational field strength is 1.7 newtons per kg? So one thing that you need to understand is that mass does not change. Mass is constant. So mass is always constant. Mass does not change. So that simply means that the mass that we are going to have is 50 kg. Okay? But weight, it changes. So you need to understand that weight is equal to mass times gravity. So weight is equal to mass, which is 50 kg, times gravity of 1.7. So weight is equal to, so 50 times 1.7, we are going to have 85 newtons. So mass is 50 kg. Then we have weight 85 newtons. So the answer is B. Number 4, the following diagram shows the motion of a ball that was dropped from a height of 2 meters and bounced back. At which point A, B, C, and D is the ball having 0 speed? The answer is D. At D, that is where the ball is having a zero speed. So what could be the reason? You need to understand that D, it represents the moment when the ball reaches the ground and bounces back at the instant. It changes direction. So its speed D, momentarily, it becomes zero. So the answer is D. Number 5. A ball was kicked vertically upwards with a velocity of 8 meters per second. How high did it rise? Final velocity squared is equal to initial velocity squared plus 2ax. So x, it represents a distance. So in this case, a ball was kicked vertically upwards. So the final velocity is 0. Okay? A ball was kicked vertically upwards with a velocity of 8 meters per second. So in this case, the final velocity is 0. Then the initial velocity is 8. Initial velocity is 8. The final velocity is 0. So you have 0 is equal to 8 squared plus 2. Then when you talk of acceleration, so acceleration, we are going to get acceleration due to gravity. So acceleration is equal to gravity. That's the one that we are going to get. So now when a ball is going upwards, so the force of gravity is going to be negative. So gravity is going to be negative 10 meters per second squared. So in this case, acceleration, which is equal to gravity, is negative 10. Why is it negative? Because the ball is going upwards. So we are going against gravity. So against gravity, that's a negative. So times x. So x, that is the distance or displacement that we are looking for. So in this case, we say 0 is equal to 8 squared, that is 64, plus 2 times negative 10 times x. So the answer is negative 20x. Okay, so this 64, it will come this side. It will be 64 is equal to negative 20x. So it was positive 64. When it comes here, it will be negative. So over negative 20 over negative 20. So negative 20 goes. X is equal to negative 20 into negative 64. The answer is positive 3.2 meters. So the answer is C. Number 6. The following diagram shows wheels used to drive a grinding mill. So we have a driving wheel which has a diameter of 10 centimeters, and we have the driven wheel which has 50 centimeters. What is the mechanical advantage? So mechanical advantage is equal to radius of a driven wheel divided by radius of a driving wheel. So mechanical advantage is equal to, so radius of a driven wheel, it is 25. You can just get 25, there is no problem. So if the diameter is what? 50, then radius is 25. So 25 divided by, if diameter is 10, radius is 5. So there we can say mechanical advantage is equal to 5 into 25, it is 5. Remember, it is a ratio. There, mechanical advantage It's a ratio, so it has no what? It has no unit. So if you want, you can say diameter of a driven wheel divided by diameter of a driving wheel. The answer is just the same. So there, the answer is C. 7. A boy of mass 50 kg runs up a flight of stairs in 10 seconds. The vertical height of the stairs is 5 meters. What is the average power developed by the boy? So there we need to understand that power is equal to work done divided by time taken. So data correction. So power is what we want. Work done we don't have. So work done is equal to force times distance. So we don't have force, instead we only have mass. So we need to convert this mass to force. So how do we convert mass to force? By saying 50 kg times 10. Okay, times 10. So that is our force. So we are converting to force. Times distance is given to be 5 meters. So distance is 5. So 50 times 10, it is 500. So 500 times 5. So we are going to have 2,500 joules. So this is the work done. Then time taken. Time taken is given to be 10 seconds. Power is equal to work done, which is 2,500 divided by the time taken, which is 10. So power is equal to 10 into 2,500. The answer is 250 watts. So the answer is C. Number 8. A copper rod is heated at one end. Which statement describes how its transfer occurs in the copper rod? So there, the answer is D. Free electrons move from the outer end to the cooler end. So should you say copper molecules, then you get it wrong. So you say energetic free electrons move from the outer end to the cooler end. Number 9. Following diagram shows a fire alarm. The biometric strip is used to complete the circuit when there is a fire. So this is the diagram. So we have the biometric strip, okay, which is a combination of two metals, metal A and metal B, and these are contacts. So the question is, which of the following statement is true when the alarm rings? So when the alarm rings, metal B, it will expand more than metal A in order for contacts to come together. So the answer is D. So metal B expands more than metal A in order for a complete circuit. Number 10. Which statement is true when a water wave moves from deeper waters to shallow waters? So there the answer is C. So wavelength decreases. 11. The diagram shows a meter loop clamped at one end and set into vibration. It produces 300 vibrations in 2 seconds. So the question is, calculate the frequency of vibrations. So we answer these questions by the definition of a frequency. So what is frequency? So frequency, it is simply the number of swings per second. The number of swings, in this case we'll say the number of vibrations in 1 second. So how many seconds do we have? 2 seconds. What's the total number of vibrations? 300. So I'll say 300 divided by 2. So the answer is 150 S. So the answer is B. If 5 seconds elapse between a lightning flash and the clap of thunder, how far away is the storm? If the speed of sound in air is 340 meters per second. So there we use this formula, speed is equal to distance divided by the time taken. So here we are looking for distance. Speed is given to be 340. Distance, that's what we are looking for. So the time taken is 5 seconds. So this is 1. We cross multiply 1 times d. It is d. Then we say 340 times 5. So the answer is 1,700 meters. So the answer is D. Number 13. The following diagram shows reflected rays from a plane mirror to an observer. So we have, this is an observer and this is the mirror. Which letter A, B, C or D shows the position of the object? So this is an observer. So the object will be on the same side with the observer. Then the image will be on the other side of the mirror. So if this is an observer, meaning the object must be this side, the image this side, on the other side. You need to understand that the distance from the object to the mirror line must be equal from the mirror line to its image. So let's look at D. So in this case, we can say that D, it is not reflecting with A because the distance is different. So this distance and this distance, they are quite different. So D cannot be the object. So the answer is C. C is the object. The distance from C to the mirror line and the distance from the mirror line to the image is the same. And C is on the same side as the what? The observer. So the answer is C. Number 14. The following diagram shows a ray of light moving from air into glass of refractive index 1.6. Calculate angle X. So refractive index is equal to sine I over sine R, where sine I, it is the angle of incidence, where sine R, it is simply the angle of diffraction. So you need to understand that the angle between the normal and the incident ray, it is called the angle of incidence. Remember that the angle between the refracted ray and the normal, it is called the angle of refraction. But you should understand that this 60 and the angle of incidence, they add up to 90 because the normal is perpendicular to the what? To the boundary there. So in this case, angle I, it is 90 minus 60, which is 30 degrees. Then we'll say the refractive index is given to be 1.6. So 1.6 is equal to sine I is 30 over sine R. So there we cross multiply, where we say 1.6 sine r is equal to sine 30, it is 0.5. So from there I'll say over 1.6 over 1.6. This goes sine r is equal to 1.6 into 0.5. We are going to have 0.3125. So from here, what we are looking for is the angle. I'm going to introduce the inverse. So the inverse function, so there the value for r is 18.2 degrees. So this is angle r, which is the angle of refraction. But our interest is not the angle of refraction. Our interest is angle x. Remember that angle x and r, they add up to 90. So we'll subtract. So we'll say, therefore, 90 minus 18.2. The answer is 71.8 degrees. So that is angle x. So the answer is D. Number 15. The diagram shows a permanent magnet placed inside the coil from the direction of the arrow. So from the direction of the arrow, this is how the magnet is placed into the coil. Okay. The question is, what could have been the response of the needle on G as the magnet was being pushed inside the coil? As the magnet is being pushed inside the coil, here is a needle. So a needle, it will deflect to the left. It will deflect to the left. That's how it will be. So there the answer is A. When we place it out, it will go on the opposite direction. Number 16. A negatively charged rod is brought close to an isolated T-shaped piece of metal. Initially, the metal is uncharged, which diagram shows the induced charge on the metal. So number 1, when we say it is uncharged, it means, this is what it means. So when we say that it is uncharged, it means that we are D, negative, positive, negative, positive, negative, positive, negative, positive. This is what it means. Then this means that it is uncharged. So that simply means that a rod is negatively charged. So when this metal, it is brought near to a negatively charged rod, so the negative charges will attract the positive charges from this metal. Then the negative charges, they will repel. So there the answer is A. So these negative charges from the rod, they are going to attract the positive charges. Then the negative charges, they are going to repel and go on the other side. 17. An immersion water heater is marked 240 volts, 2 kilowatts, and it is run for 120 minutes. If the cost of 1 unity, which is kilowatt hour, of electricity is 0.80 kwacha, what is the cost of running this water heater? So the first thing that we are going to do, we are going to find the number of units. So how do we find the number of units? So which is energy. So the number of units used. So the first thing that we are going to do is we are going to find the total number of units which were used. So the total number of units is simply energy. So we'll say energy is equal to power times time taken. So power must be in kilowatts. Time, it must be in hours. So number of units is equal to power, it is 2 kilowatts, times time. Time, we have 120 minutes. So 120 minutes must be converted to hours. So 120 minutes, it must be converted to hours by dividing with 60. So the answer is 2 hours. So 2 hours. So 2 times 2, we have 4 kilowatt hour. That is the number of units. So we've been given that per unit is 0.80 kwacha. So what do we do? So meaning the total cost. So cost is equal to 4 units times per unit, which is 0.80 kwacha. So the cost is simply 3 kwacha 20 ngwe. So the answer is A. Number 18. The diagram shows a 12 volts 3 amps lamp being operated by a transformer using a 240 volt supply. So the question is, if the transformer is 100% efficient, what current will flow from the supply? So a 100% efficient transformer, it means that the power input is equal to the power output. That's what it means. So meaning the power input, which is current to the primary times voltage to the primary, is equal to current to the secondary times voltage to the secondary. So that is for an ideal transformer which is 100% efficient. So the input power, this is the formula for power, is equal to the output power. So what do we want? We want current. Okay, if the transformer is 100% efficient, what current will flow from the supply? The supply, which is the primary. So do we have voltage to the primary? Yes, it is 240. So current to the primary times 240. Current there is given to be 3 times voltage there, it is given to be 12. So there I'll divide throughout with 240 over 240. This one goes. So current to the primary is equal to, so the answer is 240 into 36, 0.15 amps. So the answer is A. 19. The diagram shows an alternating voltage applied to the input of an oscilloscope. The sensitivity is set to 3 volts per centimeter. So this is the diagram that we have. The question is, what is the maximum voltage? This is the key. One small box represents 1 centimeter. So the maximum voltage we get from here, we have how many boxes? From here we have 1, 2, 3, 4. So that is maximum. That's how we get the maximum from the rest line here to the maximum point. So we have 1, 2, 3, 4 boxes. So here they are saying that it is 3 volts per centimeter. So it is 3 volts per one box, which is 1 centimeter. Now what is the maximum voltage per how many boxes here? 4. So there you cross multiply. X times 1, it is X. 3 times 4, we have 12 volts. So the answer is A. Number 20, a radioactive nucleus of an atom of an element emits an alpha particle. What change occurs to the parent nuclide after the decay? So there the answer is the proton number decreases by 2. Section B, figure B 1.1 is showing time recorded on a stopwatch for 40 complete oscillations by Elena during an experiment on a simple pendulum. Part A, state the time taken in seconds for the 40 oscillations. Time taken is 0, 1, 40. So this 0, 1, this is a minute, and these are seconds. Okay, so we have 1 minute 40 seconds. So now we are stating the time in seconds. So that simply means that 1 minute is equal to 60 seconds. It's going to be 60 seconds plus 40 seconds. We are going to have 100 seconds. So the time taken is 100 seconds. Calculate the period of the pendulum. So period is equal to time taken divided by number of oscillations. So period is equal to, for the time taken, we have 100 seconds. Then the number of oscillations is equal to 40. So period is equal to, so the answer is 2.5 seconds. 2.5 seconds, that is the period. Calculate frequency of the pendulum. So frequency is equal to 1 over period. So frequency is equal to 1 over period. It is 2.5. So frequency is equal to 0.4 is B2. State Newton's second law of motion. So what does Newton's second law of motion state? So Newton's second law of motion states that an unbalanced force acting on a body produces an acceleration in the direction of the force. But B, a block of mass 500 grams is pulled from rest on a horizontal frictionless bench by a horizontal force F and attains a velocity of 8 meters per second in 2 seconds. Calculate part 1, uniform acceleration of the block. So what have we been given here? So we have mass, then we've been given velocity, and we've been given time. So how do we calculate acceleration? So since velocity and time is given, so we're going to use this formula. So acceleration is equal to final velocity minus initial velocity divided by time taken. So in this case, we have data correction. So acceleration is what we want. Final velocity is 8 meters per second. Initial velocity, remember that they are saying that a block of mass 500 grams is put from rest. So initial velocity is 0. Then time taken is 2 seconds. So acceleration is equal to final velocity is 8, initial velocity is 0, time taken is 2. So acceleration is equal to 8 over 2. So acceleration is 4 meters per second squared. So 4 meters per second squared, that is acceleration. Part 2, calculate the value of force F So force is equal to mass times acceleration. So force is equal to mass is given to be 500 grams. But you need to understand that we need to change this 500 grams. It must be changed to kilogram. Okay, it must be changed to kilogram. So how do we change mass? 500 divided by 1000. So why are we dividing with 1000? We are changing from grams to kilograms. So we are going to have 0.5 kg. So that is the mass. So mass is 0.5 kg times acceleration we have. Acceleration is 4. So force is equal to 0.5 times 4. The answer is 2. So 2 newtons. Number 3, figure B 3.1 showing a simple pendulum bob of mass 200 grams swinging from position A to position E. So that is the diagram that we have. So at position B, the pendulum bob is 120 millimeters away from the ground and has a speed of 0.90 meters per second. Calculate part A, kinetic energy of the bulb. So kinetic energy is equal to 1 over 2 mv squared. So where m, it is mass, where v, it is speed. So in this case, mass is given to be 200 grams. Remember, we have to change. So we have to change from grams to kilogram. So mass is 200 grams divided by 1000. So the answer is 0.2 kg. So kinetic energy is equal to 1 over 2 times mass 0.2 times speed 0.9 squared. So kinetic energy is equal to, the answer is 0.081 joules. So that is kinetic energy, 0.081 joules. Part B, calculate the gravitational potential energy of the bulb. Potential energy is equal to mass times gravity times height. Mass, it is 0.2 kg. So 0.2. So gravity, it is constant, which is 10 times height. So the height, remember, it is 120 millimeters. No, so that 120 millimeters, it has to be converted to meters. So how do we convert it? So from millimeters to centimeters, we divide by 10. So from centimeters to meters, we divide by 100. So I'll say height is equal to 120 divided by 10 from millimeters to centimeters, and then from centimeters to meters. So there, height is equal to 0.12 meters. So that is our height, 0.12. So potential energy is equal to 0.24 joules. So 0.24 joules. But see, internal energy of the bulb. So the internal energy of the bulb, is equal to potential energy plus kinetic energy. That is the total energy. So in this case, we say potential energy is 0.24 0.24 plus kinetic energy 0.081. So the final answer is 0.321. So that is the internal energy. Question 4. Part A. Explain what happens to the particles in a solid when the temperature rises. So the question is, what happens to the particles in a solid when the temperature rises? So what happens to the particles is that particles, as temperature rises, they gain kinetic energy. And then they begin to vibrate more vigorously. So particles gain kinetic energy and vibrates more vigorously, thereby transferring heat energy from the hotter part to the cooler part. B1. Which of the three states of matter generally expands the most when heated at the same temperature? So when you look at the three states of matter, we have solid, liquid, and gas. Gas, it expands more than solid and liquid. Part 2, justify your answer in B1. So why are we saying that gas expands more than solid and the liquid? The reason is very simple. It is because particles in a gas, they are far apart and they have weak intermolecular what? Force. That is point number 1 that we can say. So particles are far apart. Intermolecular forces. So particles are far apart and have weak intermolecular forces. Then, so part 2, we are saying when heat is added, the particles, they gain kinetic energy and move faster, causing them to spread out even furthermore. Part C, a fixed mass of gas occupies a volume of 200 centimeters cubic at a temperature of 27 degrees Celsius and a pressure of 150 atmospheric. If the temperature is kept constant, find the volume when the pressure reduces to 100 atmospheric. So when temperature is constant, we talk about Boyle's law. So what does Boyle's law states? So Boyle's law, it states that the volume of a fixed mass of a gas is inversely proportional to its pressure, provided the temperature remains constant. So that is Boyle's law. So since the temperature is constant, the formula that we are going to use there, it is Boyle's law. So we say initial pressure times initial volume is equal to final pressure times final volume. You need to understand that if you increase pressure on a gas, its volume will reduce as long as the temperature is constant. So in this case, we have been given data correction. Data, we've been given initial pressure. So initial pressure, it is 150. Initial volume. The initial volume is 200 centimeters cubic. Then you have final pressure. So the final pressure is 100. Then now you have the final volume that we are looking for. So we are looking for the final volume. So now you need to understand that if you increase pressure on a gas, its volume decreases. So let's look at the solutions. So initial pressure is 150 times initial volume is 200. Final pressure is 100 times V2. So from there, we divide both sides with 100, both sides with 100, 100 goes. So we have V2 is equal to, so 2 zeros goes. So we have 2, so 2 times 150, we have 300. We have 300. So the final answer is 300 centimeters cubic. So question 5. But a person hears an explosion of fireworks from the neighbor's house. How far does the sound wave travel in air after 3 seconds? Take speed of sound in air to be 340 meters per second. Speed is equal to distance divided by time taken. So data, so speed is 314. Distance is what we are looking for. Time taken is 3 seconds. So there we have 340. Distance is what we are looking for. The time is 3. So you cross multiply. So D is equal to 3 times 340. So that is distance that we have. So 1020 meters. State one factor which influences the quality of sound. So the quality of sound is influenced by pitch, number 1. Number 2, it is influenced by loudness. Number 6, figure B 6.1 drawn to scale shows a ray of light PQ striking a mirror AB. The mirror AB and the mirror CD are at right angles to each other. QN is the normal to the mirror AB. So this is the diagram. So this is a mirror AB and also we have CD mirror. The two, they are perpendicular. So this is the normal to this mirror line. So part A. What is the value of the angle of incidence I of ray PQ on the mirror AB? So you should understand the angle of incidence. The angle of incidence, it is the angle between the normal and the incident ray. So this angle, it is the angle of incidence. You need to understand that the normal is perpendicular to the mirror line. So 50 and the angle I, they add up to 90 degrees. So the angle of incidence is equal to 90 minus 50. So the angle of incidence is equal to 40 degrees. Part B. On figure B 6.1, continue the ray PQ to show the path it takes after refraction at both mirrors. Draw to scale. So the question is, continue the ray PQ. continue the ray PQ to show the path it takes after a refraction at both mirrors. Draw to scale. The first thing that we'll do, we are going to draw a normal to mirror line CD. So that normal line, it must be perpendicular as well. Then now, from that point, I'll continue now PQ to meet the normal of CD. From there, it is going to refract like that. So part C, what is the value of the angle of refraction at CD? So at CD, this is treated as the incident ray. Then this angle, it is the angle of incidence. Then this angle, it is the angle of refraction. So how do we find the angle of incidence and the angle of refraction? Remember that the angle of incidence is equal to the angle of refraction. The angle of incidence is equal to the angle of refraction. So that simply means that if this is I is 40, this is 40, this is also 40 degrees. This is also 40 degrees. Why? The angle of incidence on AB is equal to the angle of refraction on AB. So remember that this is a right-angled triangle. So this is a right-angled triangle. So if this is 40, then we'll say 180 minus 90. We are going to remain with 90. 90 minus 40. The angle of incidence here, it is going to be 50 degrees. 50 degrees. So if the angle of incidence is 50, then the angle of refraction is what? 50. So the angle of incidence is equal to 50 degrees. Therefore, the angle of refraction is also 50 degrees. So what do you notice about the path of the ray PQ and the final refracted ray? What do you notice about the ray PQ and the final refracted? So these two, they are parallel to each other. That is what we can notice. These two rays, they are parallel to each other. Number 7, figure B7.1 shows a circuit with two resistors in parallel connected to a 10 volts battery. So we've got these two resistors, they are in parallel. We've got a 10 volts battery. So part A, what is the effective resistance offered in the circuit? So resistance is equal to, remember that the two resistors, let's say this is resistor 1. This is resistor 1. This is resistor 2. So we have two resistors. So in this case, resistor 1 and resistor 2, they are in parallel. So if they are in parallel and we only have two resistors, we are going to use a special case formula, which we say resistor 1 times resistor 2 over resistor 1 plus resistor 2. So that is a special formula. So effective resistance, which is the total resistance, is resistor 1 is 3 times resistor 2, 6 over 3 plus 6. So total resistance is equal to 3 times 6, we have 18. 3 plus 6, we have 9. So total resistance is equal to 9 into 18, it is 2. So we have 2 ohms. Part B, calculate the current flowing from the battery. So current is equal to voltage over resistance. So current is equal to the voltage of the battery is 10 divided by total resistance is 2. So current is equal to 2 into 10, it is 5. So we have 5 amps. But see, determine the charge flowing through the battery in 1 minute. So charge is equal to current times time taken. So charge is equal to current we have, it is 5, times time we have 1 minute. So 1 minute is equal to 60 seconds. So you have to ensure that your time is in seconds. So times 60. So charge is equal to 300 coulombs. B8, figure B8.1 shows a part of an electric device. Part A, identify the electric device whose part is shown. This part is coming from cathode ray oscilloscope. So that's where it is coming from. So part B, name the part labeled Q. So the part labeled Q, it is the cathode. It is the cathode. Part C, state one function of the anode. So the function of the anode, it is simply focusing and accelerating electrons to a high speed. Focusing and accelerating electrons speed. Then part labeled Q, which is the cathode. The function of the cathode, it is to emit electrons by what we call thermionic immersion. To emit, it simply means to release. So to release electrons by immersion. Part D, why is the space between part Q and the anode a vacuum? The reason is very simple. The reason is to avoid the collision of the electrons with other particles. B9, a radioactive isotope X has a half-life of 6,000 years. Part A, define half-life. So half-life, it is a time taken for the half of the radioactive substance to decay. That is what we call half-life. Part B, what fraction of the radioactive isotope X decays after 12 years? So there it is simple. Remember that half-life, it's a time taken for the half of radioactive substance to decay. So there the formula that we need to use is 1 over 2 to the power n. So what is n? N, it's a number of half-lives. So they are saying that after 12,000 years. So in 12,000 years, how many half-lives are there? So I can simply say that 12,000 divided by 6,000, which is the half-life, we are going to have 2. So 2 is the number of half-lives, which is the value for n. So I'll say 1 over 2 to the power 2. So the answer is 1 over 4. So part C, the activity of a freshly prepared radioisotope X is 4,000 counts per minute. How long will it take the activity of the sample to 4 to 500 counts per minute? So there, the formula that I'm going to use is this one. The formula that I'm going to use where NE, it means NR, it is the remaining mass or the remaining activity. Then NI, it is the initial mass or the initial activity. Then T, it is a time taken. Then TF, it is the half-life. So the remaining sample is 500. It is 500. Then the initial activity sample is 4,000. Then we have the half-life. Remember that it is 6,000. And the time taken is what we are looking for. So I'll say the remaining activity is 500. Then the initial activity is 4,000 times 1 over 2. The time taken is what we want. The half-life is 6,000. So simple, I'll divide throughout with 4,000 over 4,000. 4,000 and 4,000 goes. So I remain with 1 over 2 to the power t over 6,000 is equal to 500 into 500, that is 1. 500 there, that is 8. So I have 1 over 8. So up now we go to mathematics where we talk about indices. So in that case, I'll make sure that I've got equal bases. So in that case, I'll say 1 over 2, it's the same as 2 to the power negative t over 6,000 equals 1 over 8. It is the same as 2 to the power negative 3. So from there, I'll cancel the same bases and I will remain with negative t over 6,000 is equal to negative 3. So this is 1, we cross multiply. So 1 times t, it is t. So I'll get this one as a negative. Negative 6,000 times negative 3, I'm going to have 18,000 years. So that is the time taken. That is the time taken. Part D, suggest one precaution that could be taken when handling radioactive isotope X in the laboratory. So number 1, always wear protective clothing. Then number 2, the time of exposure to ionizing radiation should be limited. Time of exposure to ionizing radiation should be limited. And see, answer any 2 questions from this section in the separate answer booklet provided. So there, how do you choose the questions from this section? So you have to choose the questions where you're going to score more marks. So you have to go through the questions, you tick on the questions that you know that you can answer properly, then you count the number of marks, then you choose those two questions where you will score more marks. So C1, a learner carried out an experiment to determine the refractive index of paraffin using real depth and apparent depth. The following results were obtained. So the table of real depth and apparent depth is given. Part A, 1, on a graph paper, plot a graph of real depth against apparent depth. 4 marks. So the first thing that you need to do, you need to identify the axis. So the axis, we have number 1, x-axis, real depth against apparent depth. So the x-axis, it is the apparent depth. Then we have the y-axis. The y-axis, it is the real depth. So when you identify the axis, you need to choose a suitable range. So a suitable range, let's start with x-axis. So x-axis, we have 2.8 to 9.8. You can get 2 centimeters to 1 unit. There's no problem. So for x, for y-axis, we have 2 centimeters to 2 units. So you have to ensure that the graph takes half of the graph paper or 3/4 of the graph paper. So this is the x-axis. So this is 0. So remember that the x-axis is 2 centimeters to 1 unit. So we have 2 centimeters from here to here, that is 2 centimeters, that is 1 unit. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 10. Then you have to label the axis. So x-axis, it is the apparent depth. So apparent depth in centimeters. So we go to the y-axis. So for the y-axis, it is 2 centimeters to 2 units. So 2 centimeters to 2 units. So we are from here to there, it is 2 centimeters. So that is where our 2 will be. 2 centimeters to 2 units. So we have 4, 6, 8, 10, 12. We have 14. So remember that the y-axis, it is the real depth. So you need to label. So from there now, we're going to plot. So we have 2.8, comma 4. So 2.8, so we have, this is 2. So 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8. So 2.8, comma 4. So that is 4. So 2.8, comma 4. Then we have 4.2, comma 6. So this is 4, 4.1, 4.2, comma 6. Then we have 5.6, comma 8. 5, 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.6, comma 8. Then we have 7,10. 7,10, that is 7,10. Then we have 8.4,12. So this is 8, 8.1, 8.2, 8.3, 8.4, 12. Then we have 9.8, 14. So 9, 9.1, 9.2, 9.3, 9.4, 9.5, 9.6, 9.7, 9.8, 9.8, 14. So now we are going to join the points by drawing a straight line, the best fit line. So there, from this point to 0, you have to put up a dotted line, a dotted line, a dotted line. Unless if we had 0, 0, yes, it would have been solid. But now in this case, you have to put up a dotted line. That is our best fit line. Use the graph to determine the refractive index of paraffin. So how do you determine the refractive index in this case? So for you to determine the refractive index, you need to calculate the gradient of this graph. So let's calculate gradient of the graph. So gradient is equal to y1 minus y2 over x1 minus x2. So we're going to get two pairs of coordinates along the line. Now, in this case, we've been given a table. So you just get two pairs of coordinates from the table. So we have 2.8, 4. Remember that apparent depth is x. So 2.8, 4. And then we have 7, 10. So let this be x1, y1, x2, y2. So from there now we are going to substitute by saying gradient is equal to y1 is 10 minus y2, it is 4, over x1 7 minus x2 2.8. So gradient is equal to 10 minus 4, it is 6, over 7 minus 2.8. So the answer is 4.2. So gradient is equal to, so the answer is 1.43. So you don't need to put any unit. Refractive index, it is a ratio. It has no unit. So B1, an object is placed from a biconvex lens of focal length 20 centimeters. How far is the image from the lens? So the formula that we need to use here is 1 over focal length is equal to 1 over distance of the object plus 1 over distance of the image. So we've been given distance of the focal length. So we have focal length. Focal length is 20. So I'll say 1 over 20 is equal to 1 over, so distance of the object is 30 plus 1 over distance of the image. So from there I'll correct the like terms. 1 over 20 minus 1 over 30 is equal to 1 over distance of the image. So we have 1 over 16 is equal to 1 over distance of the image. Then you cross multiply. So distance of the image times 1, it is distance of the image equals 60 times 1, it is 60 centimeters. That is the answer. So the question is, state whether the image formed is real or virtual. So there, the image formed, it is real. So in part C, state one condition necessary for total internal reflection to occur. So therefore, total internal reflection to occur, the angle of incidence must be greater than the critical angle. C2, Elena carried out an experiment to determine the relationship between the potential difference V and electric current A for two resistors C and D to verify Ohm's law. The following results were obtained. Part A, state Ohm's law. So what does Ohm's law states? Ohm's law states that the current that is passing through a conductor is directly proportional to the potential difference between two ends, provided temperature remains the same. So Ohm's law states that current passing through a conductor is directly proportional to potential difference between two ends at constant temperature. Then B1, on the graph, draw two graphs of voltage against current for the two resistors C and D using the same axis for the two expected graphs. So number one thing, you need to identify the axis. X-axis, so remember they are saying that voltage against current. So x-axis, that is current. So remember that the graph must be half of the graph paper, or it must be more than half. So in this case, we are going to say for x-axis, the scale, let it be 4 centimeters to 0.1 unit. Then for y-axis, so y-axis, it is voltage. Then for y-axis, we can say 4 centimeters representing 1 unit. Our scale will be for x-axis 4 centimeters to represent 0.1 unit. Then for y-axis 4 centimeters to 1 unit. Remember, so that is for x-axis. So for x-axis, remember it is 4 centimeters to 0.1 unit. So this is 0. So 2 centimeters, 4 centimeters, that is where our 0.1 unit will be. 1, 2, 4 centimeters, that is where our 0.2 will be. 1, 2, that is where our 0.3 will be. 1, 2, that is where our 0.4 will be. And then we have 0.5. Then remember that x-axis, it is current. So I will say current. You need to label the axis current in amps. Then for y-axis, we are saying 4 centimeters to 1 unit. So 2 centimeters, 4 centimeters, that is where our 1 will be. 2 centimeters, 4 centimeters, that is where our 2 will be. 2 centimeters, 4 centimeters, that is where our 3 will be. 2 centimeters, 4 centimeters, that is where our 4 will be. Meters, 4 centimeters, that is where our 5 will be. So this is voltage. You need. So remember the rules when we are plotting. It is x, comma y. So I'll start with the resistor C. So resistor C, we have 0, 0. So this is 0, 0. Then we have 0.1, 0.5. So now this is 0.1, 0.5. So how are we counting from here to there, which is 0.1? So we need to get two boxes. 1, 2, that is 0.1, 1, 2, 0.2, 1, 2, 0.3, 1, 2, 0.4, 1, 2, 0.5, 1, 2, 0.6, 1, 2, 0.7, 1, 2, 0.8, 1, 2, 0.9, 1, 2, 1. So now 0.1, 0.5, that is our 0.5. Then 0.2, 1. Then we have 0.3, 1.5, 0.3, 1.5. Then we have 0.4, 2. Then we have 0.5, 2.5, 0.5, 2.5. Our 2.5 is. So this is resistor C. So I'm going to draw a straight line. So I'll draw a best fit line. So that is the best fit line. So this graph, that is resistor C. Then now we go to the second graph, which is resistor D. So the first one we have 0, 0, so that is 0, 0. Then the second one we have 0.1, 1. Then we have 0.2, 2. Then we have 0.3, 3. Then we have 0.4, 4. Then the last one we have 0.5, 5. So I'm going to make the best fit line. So this is resistor D. So that is resistor D. B2, using the graph, calculate the resistance offered by resistor C. So how do we calculate resistance offered by resistor C? So in this case, you need to calculate gradient. So when you calculate the gradient of this line, Nishi, you have calculated the resistance. So gradient is equal to y1 minus y2 over x1 minus x2. So from here, you just have to pick two coordinates along the line resistor C. So I'll get two pairs of coordinates from the table of values. So for resistor C, I have 0.1, 0.5. Then I have also 0, 0.3, 1.5. So let this be x1, y1, x2, y2. So gradient is equal to y1 is 1.5 minus y2 0.5 over x1 0.3, x2 we have 0.1. So gradient is equal to 1.5 minus 0.5, that is 1. 0.3 minus 0.1, we have 0.2. So 0.2 into 1, the answer is 5. So we have 5 ohms. So this is resistance for resistor C. Then part 3, using the graph plotted in B1, determine the resistor with a higher resistance. So now from here, it is very easy for us to determine between the two which one has the higher resistance. But now I want to show you using the calculations. We have already calculated for resistor C. So I'm going to pick two coordinates for resistor D. Then I calculate also resistance. Then we compare. So remember that for the values of x, they are just the same. For the values of x, they are not changing. The only thing that is changing, it is just the values of y. So for the values of x, we have the same. So for the values of x, we have the same. So the two graphs, the values for x, they are just the same. So for resistor C, for x I picked 0.1. So I'll also pick 0.1 for resistor D. So 0.1 comma 1. So this is x1, y1. Then 0.3 comma 3. So let this be x2, y2. So I have picked the same values for x, that is for resistor C and resistor D. The two resistors, they've got the same values of current, which is the x-axis. They are not changing. So now I want to know which one has the higher resistance. So I'm going to maintain the values for x-axis. So here we are D 0.1, here we have 0.1 comma 1. Here we are D 0.3, here we have 0.3 comma 3. So we have y1, which is 1, minus y2, which is 3, over we have x1 0.1 minus x2, we have 0.3. So 1 minus 3, that is negative 2. 0.1 minus 0.3, we have negative 0.2. So gradient is equal to negative goes 0.2 into 2. The answer is 10. So we have 10 ohms. So from the calculations, we can tell that resistor D, it has higher resistance. It has higher resistance. So apart from calculating using these calculations, you need to understand that the steeper the graph, the higher the resistance. So from the two graphs that we have, this graph is steeper than this one. This one, in other words, it is closer to y-axis, so it has a higher resistance. Step 3, figure C 3.1 shows 3 radioactive radiations labeled X, Y, and Z passing through a magnetic field. Part A, identify the radiations X, Y, and Z. So remember that these radioactive particles, they are passing through the magnetic field. So identify the radiations X, Y, and Z. So these radiations, they are passing through the magnetic field. So number one, again, you can identify the undifracted radiation. So the undifracted radiation, which is Y, it is gamma. So gamma, it does not diffract because it is neutral. It is neutral, so it does not diffract in magnetic field and the electric field. So Y, it is gamma. Then we have X and Z. So let's start with the beta. So beta, it is a particle that diffracts more in the magnetic field due to a small mass. Gamma, it has a small mass, so it is not heavy. So it will diffract more than beta. So as you can see Z here, it has diffracted more than X. So Z, it has more angle than X. So therefore Z, it is a beta particle or beta radiation. Then we have X, which is alpha particle. So the alpha particle, it diffracts less. It diffracts less. So even the angle there, it is small. Why? Because it has more mass than beta particle. In other words, it is heavier than beta particles. So that is the alpha particle. Part B, an isotope carbon-14, this is the symbol, decays by emitting a beta particle to produce nitrogen. Write a nuclear equation for the decay process. So for carbon, the proton number is not 7, instead it is 6. So it decays by emitting a beta particle. So write a nuclear equation for the decay process. So there we have the parent isotope, it is carbon. So which is carbon-14. So when it emits a beta particle, it is going to produce nitrogen. So remember that for any isotope which is emitting a beta particle, the mass number, it will increase by 0. So in other words, it will remain the same. Then the proton number, it will increase by 1. So it is going to be 7 plus C, the symbol of an electron. So part C, a nuclide of radium has a half-life of 1662 years. Define mass number. So mass number, it is the sum of the proton number and the neutron number in its nucleus. So that is the mass number. So the sum of the proton and the neutron numbers in its nucleus. That is what we call the mass number. Part 2, calculate the time taken for the sample of radiation to decay to 1/8 of the original sample. So how do we calculate the time taken here? Number one thing that you should consider, you should know how many half-lives are in 1/8. So in 1/8, there are 3 half-lives. Remember that 1/2 times 1/2 times 1/2, we have 1/8. So we have 3 half-lives. We have 3 half-lives. So I'll say 3 times the half-life. The half-life is 1662. 1662. So there, the answer that we have, it is, we have 4986 years. So that is the time taken. State one source of beta particles. Remember that the beta particle, it occurs naturally. So, and also a beta particle, it comes from any isotope that emits a beta particle. So, such as potassium 40, potassium 40. Also, you can say uranium or strontium 90. So that is the source of beta particle, and any other examples that we can give. So even in nitrogen, nitrogen is emitting beta particle. Even nitrogen is a source of what? Beta particle. So part 2, state one use of beta particles. So number 1, it is used to monitor the thickness of materials, such as the thickness of papers in the manufacturing process. So we can also look at the other one, also to treat health conditions such as the eye and the bone cancer.